Okay, welcome back. Here we are in section 4.4. Now, we're going to talk about congruent triangles again. In the next couple lessons, we're going to talk about congruent triangles, but we're going to do these things right here. This may not make any sense to you whatsoever right now, but in a few minutes, it'll make sense. Okay, SSS and SAS. We'll talk about what that stands for in just a minute. Let's review quickly just about congruent triangles. Say you have two triangles right here. I actually took this, copied it, and pasted it, and put it right here. And before, which is the last thing that you learn, in order to say that these triangles were congruent, you had to show that all the corresponding parts were equal to each other. So let's call this ABC, and I always go DEF. Let's try different. Let's go XYZ. All right, so this is what, in the past, what we always had to do. In order for me to tell you that they're congruent to each other, you had to show me this. You had to show me that these two sides are equal, these two are equal, and these two are equal. Okay, they're the corresponding ones. So if the corresponding sides were equal to each other, that's what you had to show. But you also had to say something about the angles. You had to say that these two angles were equal, these two angles right here, and then these two angles right here. Oops, there we go. So that's 6 things, 6 different parts, we'll call it. All right, so we had 3 sides. I had to show that 3 sides over here were equal to 3 sides here, and 3 angles here were equal to 3 angles here. I had to show 6 different things. But these things right here, okay, these are kind of like shortcuts. They allow you to only show 3 things instead of all 6 at the same time, which is pretty cool, because sometimes you can't always tell if all the information is true. Let me say it like this. You can't always tell that all 3 segments are equal to all 3 segments. You can't tell that all 3 angles here would be equal to all 3 angles over here. So there are some shortcuts, and that is this right here. And it's called this SSS. What do you think that stands for? We got 6 parts. We've got angles and sides. So what do you think that stands for? You're right. It's the sides. It's 3 sides. So what this says, if you just have 3 sides, notice it doesn't have any angles in here whatsoever. If you just have 3 sides of one triangle equaling 3 sides of another triangle, that's enough to say that your triangles are congruent. All right, let's take a look at this. We have 2 triangles right here. I don't know anything about the 2 triangles. Okay, I can't say anything about it. I can't just guess. I can't say, well, they sure look like they're congruent to each other. You can't do that. You can only go by the information that they give you. So let's say they give you some information. They say that this side PR is equal to this side LM, and they tell you that RQ is equal to NM, and they tell you that PQ is equal to LN. All right, so if they give you that information, I mean, they could give it to you as numbers, right? They could have said this is 7 and this is 7, this is 3 and this is 3. They could have given it to you that way. I just decided to put tick marks on here. If that's what they give you, that's enough. I don't have to know anything about the angles, okay? I don't have to know anything about them. All I have to know is that these 3 sides, okay, this one is equal to this one's equal to this, and this one's equal to this. If I know those 3 sides are equal to each other, I know that I have congruent triangles. And we have a reason for that, and it's actually a postulate. I think we might have mentioned this before. When you have a postulate, you don't have to prove a postulate. You just accept it as a fact. We have other things called theorems that you can prove. All right, and we will prove some of the theorems. A postulate is just something that's accepted as fact. So if I was to give you 3 just lengths that make up a triangle, if I give you 3 lengths that make up a triangle, you can only arrange those 3 lengths only one way. So if I give you these 3 lengths as like straight lines, like right here, here, and here, and I told you to make a triangle out of it, no matter who tries it, you can only make a triangle one way. That means that the 3 sides here, if they're equal to the 3 sides over here, they're going to be the exact same triangle. And you're looking at this, you're saying, well, wait a minute, that's not the same exact triangle. Well, if you do this, I'll just kind of show you. I can do this on this program. So I'll just copy and paste again. And watch what I did. The way that I changed it was let's see, I reflected it about that. I hit that. And watch this. Now, I didn't change it. All I did was flip it around. That's all that little thing you just saw did. It just flipped it around. So I'm going to take this, and I can actually put it right on top. Look at that. It's exactly the same, isn't it? Just because it's all flipped around doesn't mean that it's a non-congruent triangle. This is a congruent triangle. And what's our reason? It's called the side, side, side postulate. Now, we don't write the words side, side, side. We just write SSS. Now, we don't say it like if I asked you in class, okay, why are these two triangles congruent to each other? You wouldn't tell me the SSS postulate. You would say side, side, side. All right, so we say, let's write it down. We say side, side, and side. All right, it's in quotes. But we write this right here, just side, 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 SSS. So that's a way to prove that these two triangles are congruent. And there's another way. Let's take a look at the other way. All right, let's check out another set of triangles. Okay, I've got two triangles right here. I actually did copy and paste. They're congruent, but you can't tell right now. You cannot say that they're congruent to each other. But here's some stuff that they tell you. Right, so this is information that they will give you, or information that you will be able to figure out. You'll know what I'm talking about a little bit later. I'm just trying real simple triangles right here, and just to get us started. So what if they told you that this side was equal to this side, and this side right here was equal to this side? That does not necessarily mean that this side right here is going to equal this one, okay? Just given these two sides. Look, I could take this side, right? I could bring it out like here, stretch it out. I could do this. I'm not going to take the time to do it. I could make it a lot longer, or I could take this, swing it out here, keep it the same length, and then this one have to be a little bit longer. So they're, just because two of the sides are equal doesn't mean the third side is equal, all right? I think we had a theorem that says if two angles are equal to each other, then the third angle is equal. That does not apply with the sides. But look what else they tell me. They tell me that this angle right here is equal to this angle right here. Remember what I said? I could take this and I could swing it out right here, which will change the length of this side. Well, it'll also change the length or the measure of the angle if I did that. So right here, I'm locking them in. I'm saying, okay, I can't take this and swing it around because this angle is equal to this one. Here's another situation. If I have this situation, not three sides, but if I have two sides of one triangle, this one, this, and this one, equal to two sides of another triangle, this one and this one. If I have that situation, and if I have an angle that's in between, we call that the included angle. All right, that's the word they like to use. It's called the included, which means it's in between. This would not be an included angle because it's not in between these two equal sides. You see that? See, this angle makes up this side and it makes up this side. It's called the included angle. So if I have two sides of one triangle and the included angle equal to two sides in the included angle of another triangle, that's enough. All I need are three things. I don't need all six things to say that these triangles are congruent. You can try it. Make this length a certain length, 3. Make this length a certain length, 5. And make this a certain angle, like 40 degrees. And then try to rearrange, keeping these sides the same and keeping this angle the same. Try to rearrange it so you get a different looking triangle. You won't be able to do it. This side will always be equal to this because the triangles would be congruent, all right? So what do we have here? Well, I've got two sides and an angle. Do you remember the title of this lesson? Side, side, side. And what was the other one? It was side, angle, side. And that's also a postulate. Okay, we can't prove it. It's just an accepted thing. You could try it. You could try measuring certain things. Take a stick or something like that, okay, and have this angle or this side and this angle right here, and try to rearrange it so you get a completely different looking triangle than this. You just can't do it, all right? That just kind of shows that the side angle side postulate really works. Notice where the angle is. The angle is in between the two sides. So that tells you that this has got to be an included angle. Again, you don't have to show all 6. All you got to do is show 3. Two sides and an included angle equal two sides and included angle. And then you can say that these triangles are congruent to each other. Let's go beyond this. All right, let's say we showed that the triangles are congruent to each other. If that's true, let's do this again. I'm just going to pick it up. I'm not going to copy it. I'm going to pick it up. I'm going to put it right here. So look at that. So it lies right on top of the other one. So guess what must be true about the other parts of the triangle that we didn't say anything about, like this side AC. What do you think might be true about AC? Well, if I put this on top of this, which I just did, AC and GI were exactly the same. And so I'm going to mark it. Now that wasn't originally given to me, but once that I've proven the triangles congruent to each other, now I can say that the other parts, okay, the other parts of my congruent triangles have got to be the same or equal or congruent. So Those matched up. What else matched up? When I took this and I put it right on top of here, what else matched up? Well, the A and the G. So they must be equal to each other. Again, I didn't know that at the beginning, right? I didn't know that A and G were equal to each other, but I was able to now to say that they're congruent, the triangles are congruent. That must mean that all the parts that correspond to each other, all the matching parts, which means, what is parts? It's the sides and the angles. The matching parts must equal each other. And what else? Well, C and I, they must equal each other as well. So check it out. All the blue things, they told us right at the beginning. All right, so I said, okay, these triangles are congruent because of side angle side. There's a side angle side. So if they're congruent to each other, guess what must be true about the other parts? The other parts are equal to each other. A and G, C and I, and AC and GI, they must be equal to each other too, because I already knew that they were congruent triangles. So if I know the triangles are congruent, let's write the congruent triangles. If I knew that triangle ABC is congruent to, make sure they match up. A matches up with G, and then the B matches up with H, and then the C matches up with I. So if these triangles are congruent to each other, because of side angle side, I must know all the other stuff is equal to each other as well. And we have a little reason for that. And we shorthand it like this, Cpctc. We're going to see that a lot, right there. That's really, really important. Let me show you what it actually stands for. There's a lot of C's in here, so let's keep them straight. And they all, yeah, these two C's mean the same thing. But here it is. It's corresponding. I'll write out the whole thing. It stands for corresponding parts. Now again, what are the parts? The parts are the angles and the sides. So corresponding parts, the ones that match up with each other. If I took this triangle and sat it right on top of this, they would be the corresponding parts. The corresponding parts, put an of in there, you don't put the O, but the corresponding parts of congruent triangles, what do you think that last thing means? Are, and again, we don't put the A there for R, we just kind of, just small words, are congruent. All right, that's what that thing stands for. So make sure you understand what that means. I taught out of another book that instead of using the word congruent, they used equal. So my kids would always say Cpcte for equal. But this book says equal, or congruent, sorry, so we'll stick with what the book says. So let's say it again. Corresponding parts, right there, corresponding parts of congruent triangles are congruent. What in the world does that mean? That means this. It means if I've already proven my triangle's congruent because of side angle side, that means that the other stuff, angle A and G, C and I, AC and GI, the other parts of that triangle have got to be congruent as well. And that's what we've got right there. Again, they didn't tell us that. They didn't tell us the yellow stuff. They only told us the blue stuff. Once we know the triangles are congruent, that means all the other stuff has to be congruent as well. All right, check this thing out. This thing looks pretty weird, okay? It's something that you've probably never seen before, but you're going to see quite a bit in this chapter. I don't want it to freak you out or anything, all right? It just looks a little different. So we're all on the same page on this, okay? I don't think anybody's done this before, so nobody's ahead of anybody else. So let's just take a look. And we did a little, well, we didn't do it. I skipped chapter 2 just because I wanted to get to some things toward the end of the book. So I have to, I got to leave some things out because there's just no way I can finish the whole book in a year. So I decided to leave chapter 2 out, but there are a few things in chapter 2 that are going to be necessary for this. So I'm going to kind of teach them as I go through this. All right. So some of this stuff you've never seen before, but that's kind of what I'm doing right now, kind of showing you. What we're going to do, this thing is called a proof. All right. This is called a proof. We are going to prove something that is true. All right. This is called a proof. So first thing they do is they give you some stuff, all right? And they tell you right there, it's given, and they tell you what you want to prove. So what I do, the very first thing I do is I look at all the stuff that's given. There's 3 things, these 2 segments, and they tell you something about L. They give you those 3 things, and I'm going to mark it on my picture. It's the very first thing I'm going to do. So let's go ahead and do this. GH equals KJ. So I'm going to mark that. How I mark it? With little tick marks. Line segment GH is congruent to line segment KJ. They're equal to each other, basically. So I put little tick marks. What else do they tell you? All right, so I'm done with that. HL, let's find HL, this one right here, and JL, they're equal to each other. So I'm going to put a little tick mark here, put a little tick mark here. All right, and that's all they, well, it's not all they tell you, is it? They tell you one more thing. Now, this is a little bit different. They tell you that point L, this is L, so there's point L, is the midpoint of line segment GK. Now, what does it mean to be the midpoint? The midpoint means that it takes a line segment and it's the point that splits that line segment into two equal parts. A lot of times we say, well, it's the halfway point. You could think of it that way. It's not untrue that it's the halfway point, but I like to think of it this way, that point L is a point, the midpoint. It divides that line segment into two equal parts. That means what? If this is the midpoint, then GL must be congruent to or equal to line segment KL. They don't come right out and say that. All right, this is kind of, they tell you this is the midpoint right there, and you have to know. And how do we know? Well, because of the definition of a midpoint. The definition of midpoint basically says that the midpoint divides a segment into two equal segments. All right, so we had to kind of come up with that ourselves. This was straight up given, these two sides and these two sides. This one we kind of had to come up with ourselves with a little bit of help. Knowing that this was the midpoint, I said because of the definition of a midpoint, that these two segments are equal to each other. Now, what are we trying to do? We're trying to prove that these two triangles, GHL and KJL, we're trying to prove that they are congruent to each other. Well, so far, we only have two ways to prove triangles congruent. We only have two ways. What are our two ways, just as a review? The first way was side, side, side. The second way was side, angle, side. Do you think we can use either one of those right here? Yeah, obviously, because look, I've got one side equal, I've got two sides equal, and I got three sides equal. So I'm not going to do the angle one. I'm going to use this. I'm going to use side, side, side. So that's my reason why these two triangles are congruent to each other. Now, what I want you to do is I want you to set this up a certain way. Now, if you look in the book, they actually have three ways to do a proof. I'm only going to do one way. So no matter what it says, no matter if it says do the other two ways, I always want you to do this way. And this is called a two-column proof. This is a very common way to do a proof in high school. Now, when you get up to college and you get up to, higher level math, you might do it another way. The other way is, one way is paragraph. I'm not even going to write it down. One way is paragraph form, and the other way I think they use like a flow method or flow proof or a flow chart. We're not going to do that. I just think they make that way. They're trying to make it easier for you to understand. I think they're making it way more confusing. So I'm going to stick with one way, and this is a very, very common way that high school classes do proofs. So I'm going to stick with this way. Now, when I say two columns, we have to make our two columns. So that's going to be like the top of it, and then I'm going to split it right down like this. And there are my two columns. I've got a left side and I have a right side. On the left side, I'm gonna write, got ahead of myself. I'm gonna write statements. Okay, we're gonna write down some things that are true. And then I always have to back it up. With a proof, I always have to back up my statements, okay, with a reason. And these are reasons. All right, so I have statements, I have reasons. And this is what we're gonna do. Where do you start? The best place to start, especially when you first begin these things, is at the given. Let's find out what they told us. Well, they told us that GH was equal to KJ, so let's write that down. You could number them. I don't really care that much if you number them or not, but we'll number them. So our first step would be that GH is equal to or congruent to KJ. Now, how do we know that? How did we know that this was equal to this? Did we have to measure it? No, they told us. They told us. It was in the what? In the given. So that's all I have to write down is given. What else did they tell us? Well, they told us that HL and JL were equal to each other. So let's write that down. If you wanted to, you could put that in the same step as number one because it's got the same exact reason. I'm going to just write two different steps. So HL and JL are equal to each other, and that's given as well. Again, I could have put that in the same step and just used one reason, but that's okay. Now, watch what you don't have to do this, okay, but I like to do this. What was this? Remember, we kind of did the proof in our head already. We kind of went through it and we said, oh yeah, okay, I've got three things, or three sides equals three sides, that's side, side, side. So I know that that's going to be one of my sides. I know that's going to be one of my other sides. You don't have to do this, I think it's really helpful, and you'll understand maybe a little bit later how this can be a little bit more helpful. Now, what else do they tell you? They tell you that L is the midpoint. They don't come right out and say that GL equals KL, do they? Nope. They tell you, what do they tell you? They tell you that L is the midpoint, so that's what I'm going to write. L is the midpoint, I'll just shorthand that a little bit, of line segment GK. And again, how did we know that? We knew that because it was given as well. You're like, wow, this is easy. I just write down all the stuff that's given and that's all I got to do. Well, here's really basically the only other thing that you have to do. Let me scooch this down a little bit so I have room to write. Now, what can we conclude? We can't say just because this is the midpoint that those two sides are equal in that step right here. What we have to do is make another step. Since I know that L is the midpoint, what does that tell us? Since L is the midpoint, that tells us that GL must be equal to KL. Why? Because this was the midpoint, and the definition of the midpoint says that it splits a segment into two equal segments. So what I'm going to do is now I can say, since I've said that that was the midpoint, now I can say that line segment GL is congruent to line segment, I'm going to go KL. I'm going to go from the outside in like that, so they match up. All right, so now I can say that GL is congruent to KL. Why? Because L was the midpoint. And what tells me that a midpoint splits a segment into two equal segments? The definition of the midpoint tells me that. We're going to use that a lot. And I'll just shorthand a little bit right there. Okay, the definition of the midpoint. Guess what I can do now? I just showed my third side equal to my third side. So I can put another S right here, put it in parentheses. Now look what I have. The reason I like this is because look what I have. I've got a side, and a side. So guess what I just did with those two triangles? I just proved that those two triangles were congruent to each other. And so now I can say that triangle GHL is congruent to triangle KJL. And what's my reason for that? Let's drop this down a little bit. What's my reason? Because right here, what's in green? It's side, side, side. So that's what I'm going to write. Just side, side, side. And if you want to put the word postulate, I'll shorthand it just to post. Okay? That's all you got to do. And look at that. You have just done your first proof. It's not so bad, is it? It's a little weird. Doesn't even seem like math at all, does it? But that's what we do quite a bit of geometry. And in this chapter especially, we'll do quite a few proofs. So that's one proof on side, side, side. And let's do another one that might have some side angle side in it. Okay, here's the last one we're going to do. This one's a little bit trickier, especially at the end. The beginning's actually kind of easy. They pretty much tell you everything you need to know. So let's mark the stuff up. That's the fun part about this, okay? Just marking the stuff that's equal. BC and DC. So BC is right here and DC is right here. Give them a tick mark each. Now they tell you an angle. Angle BCF. BCF. That's this little skinny angle right there. Is congruent to angle DCE. Here's D, here's C, here's E. So that's equal to that angle right there. They also tell you one more thing, that FC, line segment FC, this one right here, is congruent to EC, this one right here. Basically, look what they did. They gave you three things. They gave you a side, they gave you an angle, and they gave you another side of this triangle. And they gave you the same thing on the other triangle. Do you see it already? I hope so. They gave you a side, an angle, and a side. So guess what must be true about this triangle right here? Okay, I'll just put a dot. That triangle right there and that triangle right there. What must be true about those two triangles? Yep, I think you got it. It's side, angle, side. So these two triangles are congruent. But look what they're trying to prove. They don't even ask you to prove that the triangles are congruent. You're like, well, what am I supposed to do then? How do I know if the other stuff is equal? Let's see what they're trying to get us to prove. I'm going to put this in another color. Now, I don't know this is true, okay? I'm trying to prove it, but I'm going to put it in another color so we can see which angles they're talking about. Angle CFD. CFD, that would be this one right there. I'll put it in yellow. Does not mean that this is equal to this. And then CEB, CEB, this one right here. So I'm trying to prove that these two, wow, they make it a little bit tougher than I thought they would. They're trying to prove that these two angles right here are equal to each other or congruent to each other. So they want you to prove that these two angles are equal to each other. Now, again, they make this a little bit tough, but let's do this first. So we know that these two triangles right here are congruent to each other. That means that the corresponding parts, remember we talked about that earlier, that the corresponding parts are equal as well. That means what? BF must equal DE. That means this angle B must equal this angle D. And this angle right here, this is what we're going to talk about. This angle right here must equal, that's BFC, must equal this angle right here. Why is this 2-arc angle equal to this 2-arc angle? Because it's part of the congruent triangles. I already proved that these two triangles are congruent. This is just one of the parts. Remember Cpctc? These are one of the corresponding parts of those congruent triangles. Now, here's the part that I didn't think they put in here until I actually started on the proof, but it makes it a little bit more tricky. We'll start off with easier ones than this on the homework, but let's do this anyway. If these two angles are equal to each other, why are these two angles going to equal each other? Well, let's think about this. Look at them. They form a straight line. So this is supplementary to this. This one right here is supplementary to this one right here. We have a theorem from another chapter. Okay, they call it, I had to look it up, they call it the congruent supplement theorem. Congruent supplement, I'll just shorthand that, theorem. And what does that say? That says if I have two angles that are congruent, I'm sorry, let's try this again. If I have two angles, this one arc and this one arc, that are supplements of equal angles, then those two angles must be equal. You're like, oh my goodness, Mr. Hamrick, you're nuts. How am I going to remember all this stuff? Well, I'm not expecting you to have full mastery of this right now, okay? I'm just getting you started, okay? We're going to spend a lot of time in class helping each other out, and that's where you're really going to learn this stuff. This is just to get you acclimated to it, okay? Just to get you introduced to it. So don't worry too much if you're saying there's no way I'll be able to do this. I bet you anything after some practice and some help in class you'll be able to do this. So let's write this proof out. So the first step, remember we were going to go side angle side. So BC is equal to DC, and let's put this all in one step. And then angle BCF is equal to angle DCE. That's all given. And what else was given? FC was equal to EC, all right? And that was all given. So I just put that in one step. And watch what I'm going to do. Remember we did this? This is one of the sides, this is one of the angles, and this is one of the sides. So look what I got. I got side, angle, side. What does that tell me then? That tells me that these two triangles are congruent. So that's going to be my next step. So I can say that triangle, let's call it BCF. Triangle BCF is congruent to triangle DCE. DC, oops, got ahead of myself. DCE. And why are they congruent? Right here, side, angle, side. So that's my reason. All right, now that the triangles are congruent, what's the next thing I want to say? I want to go for this angle right here. I want to say that these two angles are equal to each other. So let's write that down. And what do we call that angle? BFC. So let's call it angle BFC is going to be equal to angle, and if I went BFC, I'm going to go DEC. DEC. And what's my reason for that? You remember, I just proved that the triangles were congruent to each other. That means all the other parts that match up with each other are going to be congruent. And what tells you that? Corresponding parts of congruent triangles must be congruent. So you must say, in order to do this, this step has to be before this step. You have to prove the triangle is congruent before you can say that the corresponding parts are equal to each other. All right, let me scooch this up just a little bit. Okay, so now I've got this angle equal to this angle right here. But what am I trying to prove? I'm trying to prove that these one arc angles are actually equal to each other. And we can do that with one more theorem, and that's this theorem right here. So now I can say that angle, let's see, I think we make, do we want to say that they're supplementary? We do. We got two more steps. So let's do this. Let's say that, that they are supplementary to each other. So let's call it BFC so don't flip out on this, is supplementary, because I know it's confusing at first. BFC is supplementary to this angle right here. What do we call that? You can call it DFC if you wanted to. So let's call it angle DFC. All right, and in the same step, we'll do this right here. We'll say that, let's see, we went BFC. Let's do this. Let's go DEC. Angle DEC is supplementary. DEC is supplementary to this one right here. What do I want to call that? Let's go BEC. Angle BEC. Now, why are they supplementary to each other? Well, they form a linear pair. Let me see how the book says. Yep, they form a linear pair, and if they form linear pairs, then it's a then they're supplementary, because that's basically the definition of linear pair. So I could just say this. I'm just going to say definition of linear pair, because the definition of a linear pair says two angles that form a straight line are supplementary, and so that tells me that they are supplementary to each other. Now I've got one more step. Now I can say that this angle right here, okay, DFC, this one, is going to equal this angle right here, which is BEC, which is this one. So now I can say that they are congruent to each other. This was way harder than what I anticipated giving you, but it's in the book, so I figured might as well put it in there. So angle BEC. They write it in paragraph form. I just put it in two-column proof form. All right, so DFC is equal or congruent to angle BEC, and why is that? Because two angles are supplementary to equal angles. You see, we've made these angles equal to each other right here. This is supplementary, this is supplementary. If I have two angles that are supplementary to equal angles, they must be equal. What tells me that? That congruent, we'll just shorthand it, the congruent supplementary theorem tells me that. That's the name of the theorem. Well, hope I didn't scare you off too much on this stuff, okay? It's not going to be quite this difficult. Again, I think I bit off a little more than we can chew right at the beginning, but it kind of gives you an idea. It gives you a flavor for what these proofs are like. All right, so believe me, I'll give you lots of help in class. Don't fret too much over this. This is just an introductory thing, and we'll try to make sure that we get this covered when we get into class. All right, thanks for listening, and we'll see you in class.